How are you feeling? Are you
Better.
fine? Are you well?
I'm okay now. Better.
Better. Okay. So in the last lecture, where did we end, Ahmed?
So I don't know. I'm quite
Don't.
outside.
So you were outside. Outside. Okay. Nazira, can you please remind me? Did we complete oxides
Yeah,
or
yes, sir,
something?
we do. Yeah.
So oxides were complete. Oxyacids were complete. I guess we were doing something, some important compounds of group 16.
Yes.
Yes, sir.
And in that important oxygen was done. Nazira, can you see
Yes,
your
sir.
notes and last
We did till properties.
properties of sulfur dioxide?
Yes, sir.
Sulfur dioxide. Okay. So now, uh, did you guys write that it is acidic, polar, colorless gas with pungent smell? It burns with sulfur smell,
Yes, sir.
highly soluble in water.
Yes, sir. Due to formation of hydrogen bonding,
Okay, fine. Now, write
reducing
reducing.
as well as oxidizing agent.
So we have done that also. Fine. Okay. And sulfur properties. Okay, fine. Right, reducing properties of SO2. Reducing properties of SO2. It is getting positive. Okay, fine. So first we will write a general equation here. How sulfur is react as reducing agent. So if you react sulfur dioxide with water, the products that you get is SO4, 2 negative, plus 2 electron, plus 4 protons, that is 4 H plus ions. Okay, so this is the general reaction. So what is the one of the major product that you will always form is SO4 2 negative. If you are reading about the reducing properties of SO2, we will form what? SO4 2 negative.
So
First, first reaction A is it reduces. Please write it with me. Okay, it reduces ferrous. It reduces ferric to ferrous. So we have SO2. What is ferric? Maximum oxidation state, that is Fe, 3 positive, and we will get SO4, 2 negative, plus Fe, 2 positive. That is Fe, 2 positive, and we will also get plus 4 H plus ions. Plus 4 H plus ions. Please write it with me. Now here you cannot balance with hit and trial. We have to do what? इसकी टोपी उसके सर, or we say it as his hat, their head. This is plus 4, this is plus 6, this is plus 3, this is plus 2. So n factor here will be equal to how much? This will be plus 4 to plus 6 is equal to 2, and the n factor is equal to 1. So just write 2 here, correct? This will be this side, this will be that side. Now when you have written 2 here, what else is remaining? We can write 2 here also, correct? Now how many water molecules? There are 4 H positive, so we can add plus 2 H2. Next, B. Ahmed, I guess it is from your side, na? Are you out? Are you out?
no, sir.
बहुत चिड़िया चहचहा रही है तुम्हारे यहाँ.
Yes, sir. But
अच्छा, हाँ. So please mute yourself as of now. Okay. It reduces ferric to ferrous. Now, it decolorizes KMnO4. It decolorizes KMnO4. Okay. Now this reaction is used for detection of right, it decolorized KMnO4 from pink color. Okay, so KMnO4 is pink, and when you add SO2, that is sulfur dioxide, it will decolorize it for detection of SO2 gas. Okay, for the detection of SO2. What is the reaction? We have SO2 plus, in KMnO4, just write MnO4. This will be negative. Now, if you further react this, you will get SO4 2 negative, right? Plus, you will get Mn2 positive. Okay, Mn2 positive and 4H plus. Fine. H plus we can write it here, 4H plus. Okay. So now if you do balancing, this will be plus 4. This is plus 6. Here MnO4 is in plus how much state? Plus 7. Okay. Here it is in plus 2 state. So if we find the n factor, the n factor here, it will be equal to how much? It will be equal to, from 4 to 6, the changes of 2. Now here it is manganese is in plus 7 to plus 2, the change is 5. So n factor is equal to 5. Now get 2 there and 5 here. So this will be 5. This will be 2. So if there are 2 manganese here, there will be 2 manganese here also. 5 SO. We can write here what? 5 SO4 2 negative. Okay. How many oxygens? Just 4H positive, na? 4H positive. So how many oxygens? How many oxygens is remaining? Can somebody tell? Here it is having 10 oxygens here. We have 20 oxygens. And 10 plus 2H2O. I'm gonna check this now. If this is balanced correctly.
Yes, it is.
It is balanced now? Okay, fine.
Yes, sir.
Next reaction. C. Reaction with Cl2. Reaction with chlorine. Now SO2 reacts with Cl2 and it gives SO2Cl2. Thank you, Mariam. SO2Cl2. Okay. Now what is S? Now here, as you can see that it is taking the chlorine from a system and it is absorbing it. It is absorbing it. Okay. So this is also known as SO2 is also known as anti-chlor substance. As anti-chlor substance, है ना? Because as it absorbs Cl2. As it absorbs Cl2. Okay. So please, have you completed this slide?
Yes, sir.
Yes, sir.
Okay. Is anyone remaining? Abir, Mariam. Mariam was late.
What is this anti-chloro substance?
Anti-chlor substance. SO2 is also known as anti-chlor substance. Anti-chlor means it absorbs chlorine, na? So that is why it is anti-chlor. It will remove chlorine from substances. Thank you, Ahmad.
Sir, that is pink. KMnO4 from
Yeah,
pink.
KMnO4 is pinkish. It is not pure pink, but it is kind of pink. Why it is pink? I don't know. I mean, yeah, it is pink. Books write it pink. Okay. Thank you, Sania. Okay, 4 participants have raised hand. Abir, Achha, you are writing in pink. Or where are you writing? Abir is not done. Everyone is done. You are done, Abir? Did you raise hand?
No, sir, writing.
You are writing.
Done, sir.
Done? Okay. Wait a second, let me show you KMnO4 and you guys decide what color is it, okay? What is this color? Purple, pink, something?
Yes, I would go with pink,
Okay,
the one in liquid form.
in liquid form, no? So purplish, kind of pinkish, purplish color it is there, okay? This is shade between pink and purple. You guys have not seen any chemicals, now?
No, sir.
Sad. Sad, sad, sad. Okay, fine. Next, write the bleaching
I've
action.
seen chlorine.
What you have seen? Chlorine.
Chlorine, yeah.
What was the color?
Yellow type. Yellowish.
Yellowish color. Then chlorine is greenish yellowish color. Okay. D is bleaching action. Okay, so again, bleaching is also what it is, decolorizing effect, na? When we bleach something, bleach something, what happens? The color is removed, right? So SO2 also act as bleaching reagent due to its reducing power. Okay, due to its reducing power. But this bleaching action, that is, this is BA's bleaching action. Okay, Abir, Nazra, everyone. This BA is what? This bleaching action is temporary. Temporary. Why? See, if you are reducing, if you are using the reducing property of any molecule to bleach, for example, this is a substance. Now you bleached it, bleaching action took place. Now it is bleached substance. Okay, but what will happen whenever it will come in the presence of air? This air has oxygen, then it will get oxidized. So this is reducing. If it will get oxidized, it will again get back to the previous color. Okay, so it can get oxidized. So that is why it is temporary effect and not a permanent effect. This bleaching action is temporary. Now, what are the Cl2 and O2? Are strong bleaching agent. Strong bleaching agent due to oxidation. Due to oxidation. Now, Cl2 and O2, they use what? Oxygen. So you can write these reaction kind of thing also. So something is colored. If you even add hydrogen, that is, you are reducing it, it will become colorless. Do you guys know why something has color?
Because of oxygen.
I know it. Not because of oxygen.
Absence of hydrogen.
No, not absence of hydrogen.
Present.
No, not presence also. If something is color, even if you add oxygen, it will become colorless. See, it's not like this. What is this color?
Red.
Red. Okay. So whenever you have any substance which is colored, and okay, fine. If you turn off all the lights and there is some red box in your room, will you still see it as red?
No. Black.
No. It will be black. So the first thing is important, that we need light. Light to see color. Not to see color. Now, if light is not present, everything else is black. Okay. Now, what happens when any surface is getting hit by light? Now, this light is composed of. Now, I am showing a black arrow, but it is what? It is white light. Okay. This is white light, and it is consisting of all the colors that are Vibgyor. Correct? Violet, blue, green, yellow, oxygen. Oh, sorry, orange and red.
Orange. Red.
And red. Correct?
Yes, sir.
Composed of all the colors. Now, there is some property in this material, there is some property of this material which absorbs
Only a
all
particular
color.
light.
No, all color
Okay.
except red. What it is doing? It is absorbing all the colors and
Except
it
red.
is reflecting back red color.
So we see red.
So that is why we see red. Okay. Now, what is okay? Now, if some what is absorbing? What is this property? That property is unpaired electron. Okay, unpaired electron. When you have a single electron like this, okay. Now you have single electron. This will be in some kind of orbitals. Okay. Now generally we have what kind of orbitals we have? We have molecular orbitals in molecule. So and these orbitals, this may be mostly in bonding orbitals. Okay, there are anti-bonding orbitals which are vacant. Now when you hit light, and this difference between bonding, I mean not bonding, let us say occupied, this is occupied and this is vacant. Now if the difference is in energy between this occupied and vacant energy level is in the visible region, okay, if this energy difference is in the visible region, that means it can absorb one of these colors of light. What it will do, as soon as light hits, this electron will get excited and it will go in this level. Okay, now since this absorption is any one of these colors, okay, or multiple, I mean not one, many of these colors can also be present. Okay. Now somebody will ask, sir, okay sir, then where does brown come from? Brown is not in WebGeor, but you should know that some of the colors get absorbed and some get emitted. Now a mixture of, what can I say, uh, red and green or something, they can form brown color, right? So if some of the colors are getting absorbed and a few colors whose mixture is brown, they are getting emitted, we will see brown color. Is everyone clear about why do we see colors?
Yes, sir.
So the only thing is absorption of some and uh, reflection of some. Absorption and reflection of some. Light colors will give you color. Okay. So yeah, so hydrogen has unpaired electron, oxygen also has unpaired electron. That is why they combine with that unpaired electron and make it colorless. Okay, this is the bleaching action. Next, you should write the uses of SO2. Uses of sulfur dioxide. The first point, we use this as bleaching agent. Achha, just wait a second. Now somebody is at door and no one is getting it. One. Bleaching agent. Next, we have also seen that it is used as anti-chlor, anti-chlor. Then third, it is also used as disinfectant. Third point, it is used as solvent in organic and inorganic chemistry. Okay, as laboratory solvent. 5. It is used in refining of petroleum and sugars. Raise your hand if you are done, guys.
So what does anti-chlor means? Yes, sir.
अरे भाई पहले तो बताया, क्लोरीन को ये एब्जॉर्ब कर लेता है ना, तो एंटी क्लोर।
Okay, sir.
you have written ना।
Yes, sir, you wrote, but I forgot what you said about anti-chlor meaning.
Okay, waiting for Amalia, Mariam, and Sania. Just waiting for Amalia now. Mariam is also done. Okay, everyone's done. Next, we have ozone. Next, we have ozone. We have done oxygen, sulfur dioxide. This is the third one. Ozone. So what is the formula of ozone? Ozone is O3. Okay. First of all, we will look at the structure. So oxygen. So those who have studied with me in the 11th standard, they know how to draw the Lewis diagrams. So you first draw these type of oxygens, then a double bond and a dative bond here. Then it has two lone pairs. Okay, two of the valence electrons are used in bonding. There are now two lone pairs. This will have all those lone pairs. Now this can be also written as. See, this can be also written as oxygen, a double bond here, a positive charge here because there are three bonds, a negative charge here because it has how many bonds? Only one bond. Now this can show resonance like this. This negative charge can come here, this charge can go there. So we have what? A double bond B, single bond C, and C has a negative charge here. So this is the condition of a resonance now. A double bond B, single bond C, and a lone pair. We just write it like this. A, now this will be O, single bond negative here. Now here we'll have our double bond. This will be having a positive charge. So the resonance hybrid structure will be correct, partial double bonds. And what is the geometry here? Geometry, it is bent shape. It is bent shape. Correct, guys? Also write one point. Since there is a resonating structure and resonance hybrid structure here, so this bond length A and this bond length B all are same. So all OO bond are of same bond length. Okay, are same bond length. Due to what? Due to resonance. Okay, so structure is done. Next, we learn about its method of preparation. Method of preparation. Method of preparation is very easy. You get oxygen, and then you apply this oxygen into what we know as silent dielectric. Okay, here if you see this silent electric discharge, and you will get O3. So write 2 here, write 3 here. So what is this silent electric discharge? SED means high energy is required. High energy is required for the reaction. Okay, what kind of energy? High energy is required for this reaction. Okay, now another point is very important. See, O3 cannot be obtained purely in this reaction. So ozone, that is O3, is obtained, as ozonized oxygen in the reaction. What is ozonized oxygen? It is O2 plus O3. The percentage of O2 is maximum, that is 90%. That is why it is oxygen with some ozone. That is why ozone is 10%. So ozonized oxygen is O2 and O3 mixture in which we have 90% oxygen and 10% ozone. Have you guys done writing?
Yes, sir.
Yes. Okay. What about others? Amalya? Amalya is done? No. Sanya is done. Abir, done?
So 1 minute.
Mariam is done. Ahmed is also done. Amalya, Fatima, Nazira, are you done?
No, sir.
Okay, only Abir and Fatima is remaining.
I'm done, sir.
Write the next point, that is properties. So, ozone, first of all, it is diamagnetic. Okay, it is diamagnetic. Remember, oxygen is paramagnetic. Oxygen is paramagnetic. It is diamagnetic. Now, in pure form, see, in pure form, if you see ozone, it has 3 colors in 3 states. Okay, so if you are seeing the pure form, then it will be blue, pale blue gas. Pale blue gas. Okay, it will be dark blue liquid. The dark blue liquid, and it is violet solid. Okay, please write this with me. Okay, please write this with me. It is the violet solid. Next, right, small concentration of these ozone is harmless. Small concentration of O3 is harmless. But it is a very strong oxidizing agent, so higher concentration may be toxic. Okay, so higher concentration may be toxic. So strongest oxidizing agent after
The
fluorine.
strongest.
Oxidizing agent after fluorine. The most oxidizing agent is what? Fluorine, and after that it is ozone. Okay, but remember that I will ask this again question when I will teach halogens. I will again write this point. Fluorine is the strongest oxidizing agent, and at that time I will ask you which compound is after fluorine
O3.
in the oxidizing power. Then you have to answer O3. Why is it is a strong oxidizing agent? Because as it easily gives nascent oxygen. You can write this reaction O3. It can easily give O2 plus a nascent oxygen plus a nascent. Next point is also important regarding the stability, that is also thermodynamic stability of ozone. Ozone is thermodynamically unstable. What does this mean? If you have O3, it can easily decompose into what? O2. If you balance this, you will have 2 ozones and 3 oxygen atoms. Okay. Now, when we are speaking about thermodynamically, You have to remember the Gibbs equation. What is that equation? The equation says that delta G of any reaction is equal to the change in enthalpy, that is delta H minus T delta S. So we will calculate what are the qualitative values of delta H and delta S here. Okay. So if you see the delta S, it is positive. What does that mean? See the entropy here. See, finally we are getting more molecules. Initially we had 2, and finally we had 3. Initially it was 2. So if I do final minus initial, it will be positive.
Positive.
Correct? 3 minus 2 will be positive. Now delta H is negative. Arey, Ahmed, mute. Oh. Delta H is here negative. Okay. Now if we put positive in this side, here we put positive, and here we put negative. What will happen? This delta G will completely become negative. That means it is what? It is spontaneous. Right, guys? If delta G is negative, it is what? It is very spontaneous. It is very spontaneous. So please write here. Now write it with me, okay? You guys all understood now? If delta S is positive and delta H is negative, then delta G will be negative, and that means it will be the reaction. This reaction that we are talking about will be spontaneous. Okay, please write the point. Because why it is unstable? Because the decomposition into oxygen gives heat and increase in entropy due to which delta G becomes very negative and the reaction is spontaneous. The reaction is spontaneous.
Yes.
Let me know when you are done. Everyone done? Okay, who is not done? Please say no. If somebody is not done.
Me.
Okay. Me. But funny thing about me is that it is a language in India. It is known as Odia. You know, a state known as Odisha.
Yes.
Yes.
Nobody
Yes.
knows. Anna. So the state's language is Odia. And Odia also, if you want to refer to yourself, you say me. In English also we say me. In Odia you also say Ami. Ami is also very frequently used, no? Ami. What is used in
Yeah,
Arabic?
Bangladesh.
Bangladeshi is Ami, huh?
Yeah.
Yes.
In Arabic?
In Arabic,
Anna.
it is Anna.
Anna.
Okay, now is any me left or no me is left?
Sir, Marathi. I
Me
guess.
is also Marathi is also me.
Yeah.
Also. Amchi is also Marathi, na, but Amchi is mine.
Yeah, Amchi is also Marathi.
Amchi means mine, correct?
Ours, yeah.
Ours or something.
Yeah.
And also, Mala is also, I guess, Marathi, and Mala means also that very
Yes,
difficult.
sir. Mine.
Mala is also mine, na?
Yes, sir.
And when I was in Mumbai, my friends taught me one sentence, Mana yangla changla watla. Does anyone understand here? Marathi?
Yes, sir. Okay.
Now, what did I say?
So can you repeat that again?
Mana yangla changla watla.
I did not actually understand completely.
Not okay, it is something like I like
मेरी
it here.
voice लगती
I like it here.
Okay.
Okay, now oxidizing properties. We have seen that it is very highly oxidizing. So we will write some chemical reaction in which we will see the of ozone. So right here, oxidizing properties. Oxidizing properties. In oxidizing power,
So you have muted yourself.
just wait a second. Okay. There are na guests in my house, so they don't know when to come inside my room. So I was scolding them, but I don't want you all to hear my scoldings.
So you are being scolded?
No, I am scolding them. Why will I be scolded?
Oh, okay.
I am scolding them. They are coming into my room and now I am teaching na. So P4 plus O3 is equal. Now it will give you H3 PO4 plus O2. Now you will say, sir, ये hydrogen कहाँ से आया? It is done in aqueous state. Similarly, if you have S8 plus O3, again this will be in H2O. So it will give you H2 SO4 plus O3. See, oxidizing means, can you see that P here is in zero form? Now when you see P here, it is in what form? Plus 5. P S here is in zero form, and here it is in plus 6. So it is giving the phosphorus and sulfur the maximum oxidation state. That is why it is oxidizing agent. Now when you have carbon plus O3 in presence of water, you will form H2 CO3 plus O2. If you have, for example, iodine plus O3 H2O, you will form HiO3. Oh, sorry, here it will be O2 plus O2. Okay. Now remember this reaction. If you have ozone plus I negative, okay, plus I negative, it is negative, so it will first oxidize into I2 plus O2. Now again, this will be in H2O. You will get some OH negative. Okay, in some OH negative. Now this reaction is important. Why it is important? Please write a note here. Write a note. See, whenever you have iodine, na, so this can be titrated against the standard solution of thiosulfate, and then we can quantitatively estimate the iodine ion. Iodide. Oh, sorry, we can also say estimation ozone. Estimation of O3. So how will we estimate O3? Estimation of O3. See, when ozone is reacted with iodide, right? When O3 is reacted with iodide ion, it forms, see, is this balanced now? This is balanced completely. This I, is this balanced? अरे बोलो भाई. Can
No,
somebody
sir.
please? Okay.
No,
So
sir.
what do we have to add? We have to add 2 here. Okay. Now what else do we have to add? OH. 2OH.
Yes, yes.
Now it is balanced. correct?
I guess.
That is balanced now. So see, we had 1 mole of ozone and we got how many moles of iodine? 1 mole of iodine. Okay, so please just remember this. Remember this for a while. The number of moles of ozone will be equal to the number of moles of iodine that is formed if we use this reaction with ozone with iodide ion. It forms iodine. It forms iodine, which can be titrated with standard solution. What is standard solution? Standard solution is the name given to solution of sodium thiosulfate. Sodium thiosulfate solution of known concentration. We started with standard solution of sodium thiosulfate of known concentration. So what is the reaction here? The reaction is you have this reaction here, then you have this I2 plus Na2 S2O3. This will give you Na2 S4O6 plus 2 NaI. Okay, so the amount of sodium thiosulfide needed, will be equal to the amount of iodine formed, and the amount of iodine formed will be equal to the amount of ozone present in a sample. So this is known as indirect titration or indirect estimation. Okay, it's known as indirect estimation. So please complete the slide.
So what is that? Iodine which can be titrated.
Titrated.
Okay.
Titrated. Wait a second. With, don't write with against. Write it against what is generally used. Against.
Yes, sir.
What about others done?
Yes, sir.
Yes, sir.
Anyone send? Is anyone remaining? Any me remaining? No me? Is there any me? No. Sanya done? Sanya is not done. Sanya is done. Okay. Now write uses. So it is an oxidizing agent. So obviously it can be used as bleaching agent. Bleaching agent, bleaching reagent. Okay. Next, it can be also used as disinfectant or germicide. Germicide. See, all those things which have oxidizing power, now they can be used as disinfectant. Why? See, for example, peroxide is a very famous disinfectant. If you have some wound, then they will apply and उसको साफ करते हैं peroxide से. They will clean it with peroxide. Why? Because it is oxidizing agent. What happens if something is oxidizing agent? For example, there is an element A and you give it oxygen, so it will form AO. This is oxide, and usually oxides are gas. Now, if something is gas, what will happen? It will liberate out, right? So if you make oxides, and those oxides are generally gas, and those gas molecules can leave your body, and that is why they are acting as disinfectant. Now, there are many self-cleansing glasses and all. They also have some oxidants in it, and those oxidants, they give oxidation reaction. It forms oxides. Then the matter which is dirty, it gets oxidized and then leaves as gas. Third point, as disinfectant germicide. Okay. It is also used in the preparation of KMNO4. as oxidizing agent. As oxidizing agent. Okay. Done? Are you guys done writing? Now comes one topic which is important.
Yes, sir.
Depletion
Yes, sir.
of ozone layer. Depletion of ozone layer. You guys must have heard about this now. Depletion of ozone layer.
Yes, sir.
Yes, sir.
Yes. Okay. Now you have to learn about it. Generally, you have in the exhaust and all, nitric oxide is formed in the exhaust systems. Okay, nitric oxide is formed in exhaust systems. In exhaust systems, okay, and slowly deplete. Ahmed Mike, and slowly deplete the concentration of O3 in upper atmosphere. What kind of reaction does it show? Nitrogen plus O3, it will act as, ozone will act as oxidizing agent, and you will get NO2 plus O2. Okay, so due to this reaction, what is happening? Ozone depletion is happening. Please complete writing this. Then we will start another thing.
Yes, sir. Done.
Okay, is everyone done? Sulfuric acid, we will start sulfuric acid.
Yes, sir.
Okay,
Done.
done. Okay, fine, very good. The next one is, so this will be fourth. The fourth is sulfuric acid. Okay, fourth is sulfuric acid. Now, in sulfuric acid, we will start with, we know the structure, right, of sulfuric acid, or do we not know the structure of sulfuric acid? Have you guys written the structure of sulfuric acid? No. Huh? No.
H2SO4, right? Yes, sir.
H2SO4. You have written ना oxyacids of sulfur.
Yes,
इतना
sir.
सारा oxyacid पढ़ाया है, कल ही पढ़ाया है. H2SO4.
Yes.
Method of preparation. Now remember, this method of preparation is not in your this year's syllabus, but please write it. Okay. Contact process. The method of preparation is contact process. This is the name. Now in this there is few steps. In step 1. Okay, can anyone guess the step 1? It is similar to the nitric acid preparation. Step 1. No one remembers nitric acid preparation. HNO3 Ostwald process. 3 steps. The first step is oxidation of sulfur. नहीं पढ़ रहे आना आप लोग. Read daily. Then only now you will remember. Sulfur plus O2 will give you SO2. Now, second step. Step 2. Step 2 will be oxidation of sulfur dioxide. Now, when you have sulfur dioxide, react this with O2. What you will get? You will get SO3. Okay. Now there is a catalyst which is used. I have to write the catalyst name also. The catalyst is vanadium oxide V2O5. Okay, vanadium oxide, which is V2O5. All right, step 3. Step 3 is, what will be step 3? Hydrolysis, na? See, we are remaining with 2 hydrogens and 1 oxygen. So hydrolysis. Okay. Hydrolysis, if we add SO3 plus H2O, you will get H2SO4. Okay. Now, this H2SO4 is again reacted with SO3, and you get H2S2O7, which is known as oleum. Is known as oleum, and this H2SO4 is in dense form. So this reaction here, when H2SO4 is formed, it readily reacts with SO3 and it forms what? It forms oleum. Now, after that, this oleum is taken H2S2O7, and then water is added. Now, this oleum is pure sulfuric acid. There is nothing in this oleum. Okay, oleum is pure sulfuric acid. Now, if you add H2O as per your need, as per your desired concentration, you will get H2SO4. Okay, desired concentration. Desired concentration. So can somebody balance this reaction? H2S2O7 plus H2O.
Sir, 2H2SO4.
2?
2H2SO4.
Okay, yes, it is balanced now.
Yes, sir, it is.
Let me know when you are done.
Yes, sir. It is.
What about others? Is anyone writing? Still writing? Is anyone still writing? Acha,
Done, sir.
Soumya.
Done, sir.
Fatima is here. Who got disconnected? Mariam got disconnected. Done, everyone?
Yes.
Okay. Okay. Now write properties. Now, this chemistry that we are learning is known as descriptive chemistry. Yeah, in organic chemistry, and we are learning descriptive. That means we are just describing a few things, and you have to. Can you hear that rooster? Is the rooster audible?
Yes.
पागल हो गए सब सारे के सारे animals even. Now it is 4. Yeah, it is 4 around 4:30 in India. और इसको लग रहा है सवेरे का 4 बज रहा है. It thinks that it is morning. It is dawn 4:30. Colorless liquid. Okay, this is colorless liquid. Second point is dense oily liquid. Okay, due to strong intermolecular hydrogen bonding. Okay, due to intermolecular hydrogen bonding. Okay. Now, what is the basicity? It is acidic in nature and it is dibasic. The third point is it is a strong acid and dibasic. Right? We have written in H2SO4 it is dibasic. Why it is dibasic? And let us see the basic nature of H2SO4. H2SO4. Now, if we have the first dissociation of hydrogen, you will get H plus and you will get HSO4 negative. Okay, HSO4 negative. Now, this is known as Ka1, the dissociation constant of acid, and the 1 means first dissociation constant of acid. Now, again, we can remove one more hydrogen from here, which is HSO4 negative. This will give you H positive, plus it will give you SO4 negative. Sorry, SO4 2 negatives. Because there was 1 negative, we removed one more positive charge, so this will be 2 negative. This will be known as second dissociation constant, right? Ka2. This will be Ka2. Now, I am saying that Ka1 is very, very high than Ka2. Why? What is the reason? The reason is that, see, Here we have neutral substance and we are making an anion. Now removing a positive charge from a negative charged anion is more difficult, because if you have some anion, then it will attract the positive charge and it will not let the positive charge to get liberated. Correct? That is why what is happening here in HSO4 negative, what is Ka1 is higher than, very higher than what? Ka2. Why? Because anions does not let the proton to leave. It does not let the proton to liberate. Okay. Did you guys understand this point?
Yes.
Regarding the Ka1 and Ka2? Yes, everyone? Yes, no, please say something.
So can you explain again?
Yes.
Yes, I can explain again. Okay. You answer me, Abhi. There are two things. Now here, H2SO4 is neutral, correct?
Yes, sir.
Doesn't have any charge. And then we are removing a positive charge from a neutral substance. Okay. In the Ka2, dissociation constant 2, what we are doing, we are removing a positive charge from a negatively charged species. So there is a negative charge here, and we want to remove a positive charge from here, H positive. So this negatively charged anion, it will be attracting the H positive, correct? And it will not let H positive to get liberated. That is why the Ka2 is difficult. That means the rate of, the dissociation constant is high for the first case. It is easily dissociated. And the second case, it is difficultly dissociated, right?
Yes, sir.
Okay. Now, it is also a strong oxidizing agent. Okay, are you guys done?
Yes, sir.
Yes.
Okay. Next point, oxidizing properties. Mariam, why is the internet connection so unstable today? Is Mariam here, or she is again disconnected? Oh, she is here. It's not the internet. Okay. Oxidizing properties. H2SO4 is a strong oxidizing agent. Strong oxidizing agent. Let's see. If you have H2SO4, now if you add some non-metal, okay, Mariam, H2SO4, and you will get SO2, plus you will get H2O, plus you will get nascent oxygen. That is why this is what? It has oxidizing properties. It has oxidizing properties. Let us write some reaction. If you have carbon, plus you have concentrated H2SO4, what you will get? This carbon will get oxidized to CO2 plus SO2 plus H2O. Second case, you have sulfur plus concentrated H2SO4. What you will get? You will get SO2 plus H2O, right? Not 2 times H2SO4, not 2 times sulfur dioxide. Conc H2SO4. Third one is, if you have phosphorus plus you get conc H2SO4 to it, you will get H3PO4 plus SO2 plus H2O. Okay, plus H2O. You can write a reaction with metal also, no? You have seen the non-metals. Metals, copper, you can write conc H2SO4. You will get CuSO4. The CuSO4 is 2 negative plus SO2 again plus H2O.
Yes, sir.
Yes, what about others done?
Yes, sir. So in the second reaction, we should put 3 sulfur in the reactant side.
Reactant sides. No. See now, 2 sulfur is here and 1 sulfur is here. So 3 sulfur is there now already
Okay, sir, yes.
from H2SO4. Your schools are starting offline from October.
Yes, sir.
Not
They
sure.
said that
First of
we will
October.
not be providing. Yeah, I guess so. But from October, not September.
I mean, will it be compulsory kind of thing or?
So we don't know about that yet. But they said that we all must they advise the parents, those who are about 12 must be vaccinated before this duration.
Okay. And the
And
liability
also
will
they
be
said
on you guys or the school if something happens. It's not compulsory. Mariam is saying.
and they also said that the school will not be providing transportation.
That is. I mean, it is. And what can we say? If school, you all go in buses, na? School buses.
Yeah, I do go on bus, so I might not go to school.
In India
That's
also.
fine for me.
In India also that is the problem because schools are permitting that yes you can come to school, but they are saying that we will not send any transportation. Now the parents also cannot go 1 hour, 2 hour. No, some schools are very far away. In Delhi, in cities, this is the problem.
So
But in
here
my
schools are not very much far. Like we can reach school within 15 to 30 minutes, like maximum 30 minutes. For me, it
if
is
you don't
around
have,
8 minutes on
you
bus.
don't have
Or
driving license and those kind of things, so you
I
cannot
have
drive.
driving license, but no
But
car.
Acha, car is not wrong. And bike is not very common in Middle East, I guess, right?
Yes, I have applied for bike license also, but my parents are like, you don't have to take bike license over here. Like the safety is less, and
Safety is less. Also, in Middle East, you don't see many bikes. Bikes as in motorcycle, not
yeah,
that cycle. So many people say cycle also bike, no? Okay. Next, write dehydrating properties. Only in winter we see. Okay. Dehydrating properties. Right here, concentrated H2SO4. Concentrated H2SO4 is a strong dehydrating agent. Is a strong dehydrating agent, as it has strong affinity towards this is one of the mistakes that I have been doing since my childhood. Rather than writing D, I write G. Does this happen with anyone else?
I write B instead
So
of
you write
D
instead of D. I
sometimes.
usually write G instead of D towards H2O. Now see those reactions. C12, H22, O11. Acha, you also do. Mariam, what do you write? D or G? I mean B or G?
I write G and then I correct it.
Acha, same mistake, I guess. I also do that. I don't know how. I mean, why do we do this? There must be some psychologist who will be working on this mistake, I guess. Okay,
Maybe
C12
I'm
H22. What are you saying?
nothing.
Okay. What is this? C12 H22 O11. I'm expecting answers from biology student. I am disappointed. Sucrose. Okay. If you have C6, H12O6. Now what is this? Oh, very good. Wow,
The sugar,
it is glucose.
like C12H22O11 is sugar, table
Yeah,
sugar.
that is sugar, but it is sucrose. Sugar, any carbohydrates you have na, in chemistry, we say call it sugar, but this is table sugar, not sugar. This is table sugar, the sugar that we use. For example, if I say KCl, what is this? This is salt, na?
Yes, sir.
KCl is a salt. Now, what is NaCl? It is table salt,
Yes, sir.
right? That is, I mean, the same difference. Sugar is a generic term. H2SO4. Now, how many water molecules will we get? 6 H2O plus 6 carbon. Okay. Now, if you have oxalic acid, COOH whole twice. The structure of oxalic acid is like this. Okay. This is oxalic acid. You react this with concentrated H2SO4, H2SO4. How many H2O molecules will we get? One molecule of H2O plus. You will get carbon monoxide plus you will get carbon dioxide. Okay. Next, if you have carboxylic acid, that is HCOOH, react this with concentrated H2SO4, you will get H2O plus carbon monoxide. Now, in the note kind of thing, let me make some space here. Now, right here, charring action of, or rather, charring of sugars or carbohydrates. So this reaction, these two reactions, okay? These two reactions we are talking about charring action of carbohydrates. Now in charring action of carbohydrates, what happens? Sugar or carbohydrates anodized, become black in the presence of H2SO4 as it removes water from it. This is known as charring action of sulfuric acid. Known as charring action of sulfuric acid. Okay.
So concentrated H2SO4, right?
Concentrated H2SO4. Now in the same slide I'm writing uses, just copy this uses, okay? So these carbons, these are black in color, okay? These are completely black in color. Now in uses, what will be the first? There are uses in petroleum refining. Now it is also used in manufacturing of fertilizers. Third is it is used in manufacturing of paints and dye. Now as oxidizing agent, it is also used. Right, 3 uses, that is enough. If you see your NCERT, I mean, they have stated till I guess G. H2SO4 uses they have stated till G. You can refer the NCERT if you want to write more uses, okay? Right, fourth one, write one more as laboratory, what you can remember as laboratory reagent. Okay, is used as reagent. If you remember, sulfonation reaction, nitration reaction, electrophilic aromatic substitution reactions of benzene and benzene derivatives, in that we use H2SO4. Also, it is yes, okay, Mario.
This sugar or carbohydrate becomes what?
Black. Should I rewrite it?
Yes, sir.
Okay, what about others? Done?
Yes, sir. Done.
Okay, is there anyone who has not done? Okay, everyone is done. Okay. In allotropes of sulfur, now there was one point. Did I tell you about rhombic and monoclinic sulfurs?
No, sir.
Okay, so right one. Allotropes of sulfur. Okay, there are two types. Allotropes of acid. Acid can be found in the crown ether, na? And crown ether sulfur. It can be either formed in rhombic. You remember solid state rhombic, and there is one monoclinic sulfur. One is monoclinic sulfur. Okay, in these two sulfurs, write some remarks. First point, rhombic sulfur is stable. No. Wait. Let me rephrase it. Okay, let me just rephrase it. At room temperature, sulfur is found in rhombic form. Rhombic form, I wrote. Rhombic form. Sulfur is formed in rhombic form. Now, second point, below 369 Kelvin, rhombic sulfur is stable. Above 369 Kelvin, monoclinic sulfur is stable. At 369 Kelvin, both forms are stable. Both forms are stable and they are in transition state. Okay. So, for example, if I ask someone, I asked this to my my sister is in 8th standard. I asked her कि पानी कितने डिग्री में फ्रीज होता है? She was like 0 degrees Celsius. And I asked her कि at what temperature water get freezes? She answered 0 degrees Celsius. Okay, fine. I asked her at what temperature ice melts? She said 0 degrees Celsius. So what is stable at 0 degrees Celsius? Is ice stable or water stable in liquid form? So both are stable at 0 degrees Celsius. They are in equilibrium, okay, in the transition state. They are in equilibrium and in transition state at 0 degrees Celsius. Both ice and water. And similarly here, 369 Kelvin is for rhombic and monoclinic sulfur. Both the forms of sulfur are stable in 369 Kelvin. But if we go below 369, the rhombic will be stable. If we go above 369, monoclinic will be stable. Okay. Write this. Then we will start group 17. Okay, we will start group 17. Is everyone done?
Yes.
Yes, sir.
On Wednesday, I will try to complete this chapter.
By Wednesday or from
No, on Wednesday.
okay.
On Wednesday we have classes, na? Right, group 17.
Yes, sir.
Group 17. These are what?
So group
Halogens.
16 is finished.
16 is finished. Very fast, na?
Yes, sir.
Okay. I said na group 15 will take very much time. Do you know? We have taken approximately, I guess, 18 to 20 hours in group 15. I guess that much hours. I guess there were some 1 hour class and 1.5 hour class, but still we had taken 10 classes for group 15. Now group 17. Group 17 is known as halogen. Halo means salt, and gen means generator or forming. So these are salt forming compounds, and hence they are named as halogens. Okay. So just to remind, group 15 is known as what? Nitrogens. 16 is known as what? Chalcogen. 17 is known as what? Halogens. Nitrogen means it is choke generating. Chalcogens means it is ore forming. Halogens means it is salt forming. Delete this. Now halogens. What are the elements in halogen? Halogen we have fluorine, chlorine, bromine, iodine, and astatine. We have fluorine, chlorine, bromine, iodine, and astatine. The atomic number for fluorine is 9. Now chlorine will be add 8, will be 17. Now after 17 we will have 35 as bromine. Iodine will be 53 and astatine will be 85. Okay. Now please write this with me. Now we will write the electronic configurations. Now electronic configurations. So start here. Fluorine will be helium, S2, 2p5. Fluorine will be after helium comes neon, 3s2, 3p5. Then comes bromine, and here it will be argon, 4s2, 3d10, and 4p5. Then comes iodine. Iodine here it will be krypton, 5s2. I hate my 5. 5s2, 4d10, and 5p5. Now in astatine we will have xenon. This will be 6s2, 4f14, and 5b10, 6p5. Okay, so this astatine is radioactive. It is radioactive. Its chemistry is not well established. Its chemistry is not well established. So all are non-metals. It is also radioactive non-metal. Okay, this is also non-metal. All are non-metals. Okay, all are non-metals. What is the valence electron? Valence electron is how much?
7.
Yes, 7. Valence electron is 7. If I tell you to write the general electronic configuration, so you will write it as NS2, NP5. NS2 and NP5 for group 17, NS2 and NP5. Okay, general electronic. This is important for us, na? That valence electronic configuration or general electronic configuration for group 17 will be NS2, NP5. Okay, let us write here only the oxidation state, the first property that we. Okay, are you guys done?
Yes, sir.
Can I move on?
No, sir.
Asha, okay. So again, you know the drill here, right? We will first of all talk about the oxidation states. What are the available oxidation state? Then we will learn about the atomic size. After we learn about the atomic size, we will learn about the ionization enthalpy. Then we will learn about the physical state. Then about the electron gain enthalpy. Okay. So these are the major properties. 5 major properties. Okay. Done.
Yes.
Yes, sir.
Okay. So let us start. Number 1. Oxidation state. Okay. So oxidation state. What will be the oxidation state here? From valence electron -8 to
Valence electron.
valence electron. So -1 to +7. Okay. Now let us write the whole oxidation state. So this will be -1. You can also see this in 0. You can see this in +1, +3, +5, and +7. Okay. +3, +5, and +7. In these oxidation states, you can see the halogens. Next, fluorine. Yeah. Fluorine. You have
Sir,
to write
these
about
are
fluorine.
common oxidation state.
These.
Yes, sir.
You can write, I mean, most dominantly it will be in -1. Okay. Most dominantly it will be in -1, but it can show these oxidation state also, except fluorine. Fluorine will not show the higher oxidation states. Okay, let me write that point first. Fluorine always shows -1 oxidation state. Okay, now -1, but somebody will say that in F2 it is in what oxidation state? 0, right? So it will always show -1 oxidation state with other atoms. Why? Because the fluorine is most electronegative. So even if you have fluorine and oxygen, so F2O, in here also fluorine will be having -1 oxidation state. Okay, it will be having -1 oxidation state. It will not show any positive oxidation state because due to its highest electronegativity, right? Fluorine is most electronegative. That is why it cannot show positive oxidation states. Okay, the other halogens, they can show this -1 to +7. Higher halogens can show higher oxidation states due to presence of vacant d orbitals. Presence of vacant d orbitals. Okay. Next, we will learn about the atomic size. Atomic size. Now, in atomic size, we have fluorine, chlorine, bromine, iodine, and astatine. You know that from top to bottom, what happens? Size increases, right? So this will be order for the size, correct? Then physical state or okay, right? Physical state. In physical state, we have F2. Okay, wait a second. We have F2. Okay. Then we have Cl2. Then we have Br, and then we have I2. Okay. So these two are gases. Br2 is liquid. Bromine water. Do you remember bromine water? In reactions of phenol, there is one reaction in which we
Yes.
have bromine water, and we form tribromophenol. This is solid. Okay, this is solid. Now, fourth point. Fourth point, write about ionization energy. Okay, I think you guys know ionization energy. What is the order ionization energy? from top to bottom. See, if the size increases, what will happen? Ionization energy will decrease, right? At the later, I mean the higher groups, in the higher periods, in the lower in the group, what happens? The size increases, ionization energy decreases. So fluorine will have the highest, then chlorine, bromine, then iodine. Okay. Most of the time, we will be just looking at these four: fluorine, chlorine, bromine, and iodine. Okay. Not acidic because it is radioactive. Carry is done.
No, sir.
Whose mic is on?
Yes, sir.
Done, sir.
Done. Okay. Next, write electron gain enthalpy. Electron gain enthalpy. What will be the order? Electron gain enthalpy. Usually, what happens when if we have smaller molecules? Yes, tell me.
From top to bottom, it decreases.
Yes, from top to bottom, what happens? It decreases. But as we saw in oxygen, in the group 16 elements, also we saw that. So here also chlorine will have higher electron gain enthalpy than fluorine, than bromine, and then iodine. Because again, you remember oxygen and sulfur we compared. Oxygen has how many electrons? 6 electrons. Sulfur also have how many electrons? 6 electrons. But sulfur is larger in size. Oxygen is smaller in size. And the incoming electron faces repulsions. Do you remember this point? We have written in oxygen also.
Yes.
Let's note it, na? Okay. So similar point and similar reason you will write for fluorine also. Okay. The expected was what? That fluorine should have higher electron gain enthalpy than chlorine, but the fluorine has higher electron gain enthalpy due to the compact size of fluorine. The incoming electron faces repulsion. Now write a note. Write a note. The note is halogens have the highest electron gain enthalpy in their period. Highest electron gain enthalpy in their period. Why? Due to their small size and high effective nuclear charge. See, this is again class 11, chapter 3, periodicity. In that periodicity also we see the electron gain enthalpy. What is the reason? Small size and high effective nuclear charge. Halogens accept the incoming electron accepts the incoming electron and acquires. Now, can you think if you have fluorine, how many electrons? 7 valence electron. If you add an electron, you will get fluorine negative, but this will be what? Stable noble gas configuration, 8 electrons, right? Incoming electron and acquires stable noble gas configuration. So these halogens are just shy of 1 electrons to get the noble gas configuration, right? Next, 5th point, now write 6th point is bond dissociation energy.
That reaction we won't write.
It is not a reaction. I was just explaining it. That from 7 electrons, you will get 8 electrons.
Okay, sir.
Bond dissociation energy. So if you will have small bond, the dissociation energy will be required, will be high. If you have long bonds, it will be small. So small bonds can be formed between small atoms. Large bond is formed between large atoms. Correct. So what will happen from top to bottom?
The bond
We write
dissociation
bond dissociation energy
decreases from top to bottom.
is inversely proportional to size of atom. Okay, it is inversely proportional to size of atom. So what is the order? The order will be
F,
F2,
F2,
CH2,
Cl2, Br2,
Br2, I2. But this is not right. This was expected. The actual is
Cl2.
fluorine. Not see fluorine and fluorine bonds. This is a single bond. How many electrons does it have?
7.
7. One is in the bonding, and
Yeah.
there are 6 lone pair electrons. Now, can you imagine the electronic repulsion that it will these due to this lone pairs? Right. So
Yes,
it is
sir.
so high. Right. It is so high that first of all we have Cl2, then we have Br2, and
Yeah.
after that we have F2, and after that we have I2. Okay. After that we have I2. Now write also the reason here. What is the reason? Due to small size of F, the inter-electronic repulsion. Remember the same point we have written in nitrogen also, but in that we have stated that nitrogen single bond is not stable, right? Single bond is the nitrogen single bond is weaker than phosphorus single bond due to inter-electronic repulsion between the lone pairs. Here also what we will write, due to small size of fluorine and inter-electronic repulsion between the lone pairs, the cleavage of FF bonds becomes easy, and hence the bond dissociation energy, this is BDE, is high. Bond dissociation energy is high. See, again, I don't have to explain much because we have explained in nitrogen only.
Yes, sir. Done.
Done? Okay. Is everyone done? Is
Yes.
someone writing?
Yes,
No one is
sir.
writing? Done? Okay, fine. Next, boiling point and melting point. All are non-metals, so we don't have to write much here. Now this will be 7th, I guess, right? Boiling point and melting point. Okay, boiling point and melting point. Now here in boiling point and melting point, all are non-metals. Therefore, boiling point and melting points will be directly proportional to molecular weight. So F2, then Cl2, then Br2, and then I2. Okay. So this boiling point and melting point is are directly proportional to molecular weight, and we have also seen that this is gas. This is also gas. Now this is what? This is liquid, and this is solid. So that also confirms this trend in boiling point and melting point. The next thing is color. 7. This will be 8. Color. Okay. All halogens are colored. Yes, Ahmed, what is the color of fluorine?
Sir, done.
I don't know. You said you have seen fluorine. You just answered in the starting of this class. You don't know.
I said
Pale yellow.
fluorine.
What did you say?
Chlorine.
Chlorine.
Yeah.
Chlorine is what? Chlorine is greenish yellow.
Yeah.
It's not.
I said
I
yellow.
thought it's yellowish. Br2. It is red, or you can say reddish brown. This brick color. Reddish brown. I2 is violet.
So the melting and boiling point are same. Like the
Yes,
orders are
yes.
same.
Yeah, the trend is same.
Okay, sir.
Because they depend only on one thing, on melting point. Oh, sorry, on melting point. I'm saying they depend only on molecular weight.
Yes, sir.
Okay. So this is very important. Please don't write it now. Okay. Just listen here. Oxidizing power. This is ninth. See, what is the electronic configuration? NS2, NP5. So if I give it one electron, now please remember this concept of oxidizing power is very important, because if you are oxidizing something, that means you are taking electrons from it. There's A, you take electrons from it. If it is zero state, it will become A positive, right? So this chlorine, this halogen should have the tendency to accept electron, right? It should have the tendency to accept electron, and as it accepts electron, it will act as oxidizing agent. Okay, and it will have the configuration NS2, NP6. Now this is what this is: noble gas configuration, stable configuration, stable electronic. Please don't write configuration. So due to this NS2 and NP5 configuration, halogens easily accept an electron and act as strong oxidizing agent. Strong oxidizing agent. Okay. Now see the order of oxidizing power. Okay. The order of oxidizing power: fluorine, bromine, iodine. Okay. Also write one point. Fluorine is the best oxidizing agent. Nazira, what comes after fluorine in oxidizing power? Which is the
Ozone,
second most?
O3.
Can you
O3.
speak? Nazira also said O3.
Yes.
Good. Fluorine is the best oxidizing agent. Now you will have a question, sir. Here also it is accepting an electron, and here also it is accepting an electron. But here we said that chlorine had higher electron gain enthalpy. That means the tendency to accept electron was higher of chlorine, but now you are saying it is higher of fluorine. Why is that? Now you have to remember one point, that whenever we talk about electron gain enthalpy is calculated in gaseous state. Okay. Now write this point. No, not right. Just see this point. Electron gain enthalpy is calculated or measured in gaseous state. Okay. But the oxidizing power is measured in aqueous state. In aqueous state. Okay. And oxidizing power, you will read this in electrochemistry chapter. There is one thing which is known as standard reduction potential. Okay, standard reduction potential. So if we calculate the standard reduction potential, now the tendency to reduce. So the tendency to reduce should be smallest. Now this depends on delta bond dissociation energy. Okay, let me first write it like this. See what you have fluorine 2. First of all, what will happen? You will get 2 fluorines like this. Okay. So now here what we are doing, this is delta H bond dissociation energy. So the bond dissociation energy of fluorine will be measured here. Then what will happen? This fluorine will get an electron and it will get fluorine negative. Now this step here is delta H electron gain enthalpy. Whatever energy is required or liberated in this step will be known as electron gain enthalpy. Now there is another step which is very important when you have aqueous. When you have water, when you have H2O, you will have delta positives here in the hydrogens. Now this delta positives can solvate this F negative, right? There will be some attraction here. This is known as hydration. So known as hydration energy. So here you will have F negative plus H2O. This will make it F negative aqueous. Now this process is known as delta H. The energy that we will calculate, we will put this in the delta H hydration. If you remember a bit of thermodynamics, do you remember in thermodynamics we used to do this kind of calculation and we used to write it like this? You don't remember. In the standard reduction potential, it is equal to the sum of all of these things, delta H of bond dissociation energy plus delta H of electron gain enthalpy plus delta H of hydration energy. Okay, standard reduction potential. Now let us compare between fluorine. Here we will write regarding fluorine and chlorine. Okay. Now bond dissociation energy, whose is higher? Fluorine has low bond dissociation energy and chlorine has higher bond dissociation energy. Can you see here? Fluorine has higher bond dissociation energy. Fluorine has lower bond dissociation energy. Correct? Please,
Yes, sir.
someone. Okay. Now what about electron gain enthalpy? Fluorine has lower electron gain enthalpy and fluorine has
Hi.
higher again electron gain enthalpy. But now let us compare the hydration enthalpy. You have H positive and fluorine negative. Okay, you have H delta positive, fluorine negative. You know this. What will be the difference in size? Fluorine and hydrogen won't have much difference in size. Also, one more thing. Now this is here what? This is known as hydrogen bonding. Now this is only dipole interaction. Okay. Now this will constitute more than hydrogen bonding because fluorine is completely negative. This is completely negative. Okay. So that is why fluorine can easily interact with H positives. That is why this hydration energy becomes very, very, very high for fluorine. And this for chlorine, there will be some hydration enthalpy. Now this is the reason. This is the reason why we say that fluorine is the strongest oxidizing agent. Is the strongest oxidizing agent. If you write these 2 points, that will be enough. And just write one more point. The hydration energy is energy of fluorine negative is so high that it makes fluorine the strongest oxidizing agent. It makes it the strongest oxidizing agent. Done? Okay, is anyone writing, still writing, or is everyone done?
Yes, right.
Sir, writing.
Okay. Still writing?
Yes, sir.
Yes, sir.
These girls don't wait or what? Sania, Nazira, Amalia, Fatima, you are done?
Yes, sir.
सुन नहीं रहे थे आप लोग यानी? लिख रहे थे ना? अल्लाह करे कुछ नहीं आया आप लोगों को. बहुत बढ़िया. Very good. Very good. Sania is done.
Yes, sir. Done.
When I was explaining, these girls were writing. If you have written, read it 10 times. तो हम ऐसा दुआ करेंगे ना, कुछ नहीं आया आप लोगों को.
You said that is called curse. But what?
नहीं हम तो दुआ कर रहे हैं. Done? Ahmed, Abir,
Yes, sir.
you don't need to write this, okay? Because you will have MCQ type of questions now. Just write these 3 points, read these 3 points, that will be enough.
Yes,
Now,
sir. Done.
chemical properties of group 17. Can you see the speed now? You guys know everything. Chemical properties of group 17. So the first will be reaction with reactivity towards. अरे यार तीसरा ग्रुप है, आप लोग को याद होना चाहिए. रिएक्टिविटी टुवर्ड्स no one remembers. Tell me what I going to teach.
Reactivity towards halogen.
Halogen. Wow.
No?
We will read reactivity towards hydrogen.
Okay.
Reactivity towards hydrogen. That is the first point. Okay. Now reactivity towards hydrogen. So all of the hydrogen will form. All halogen form. So they will they form hydrides? No, they will not form hydrides because hydrogen will not be more electronegative. No? So all halogen react with hydrogen and form EH. Okay, EH type of compounds. The first point regarding these type of compound is their bond is bond energy. Okay, bond energy. Bond energy or bond dissociation energy, those are same thing. Bond energy or bond dissociation energy. We know that bond energy is inversely proportional to size. So we have HF, then we have HCl, then we have HBr, then we have HI. So if you look at the size difference in HF is very small. That is why they will form more strong bond, and this will be the order. Now part B is acidic strength. We have seen the acidic strength, right? We have seen the acidic strength. What happens in a group? Hydra acid, no? It's a hydra acid. So in the group 15, we have learned about the acidic strength of hydra acid. So in group,
Yes.
what happens? The acidic strength is proportional to size, right? Directly proportional
Yes,
to
sir.
size. So HF, HCl, HBr. Please write these things with me, okay? HI.
Okay, sir.
Also because this has low bond dissociation energy. HI will easily dissociate, and that is why it is stronger acid. That is why it is stronger acid. Okay, next point. B. Now C. Reducing power. Whoever will give more easily the hydrogen, it will be more reducing, no? It will have more reducing power. So HF, HCl, HBr, HI, due to low bond dissociation energy. So that this is thermal stability. So thermal stability, we have written it so many times, is directly proportional to bond energy. Okay. So if something has higher bond energy, it will be also needing higher temperature to get dissociated or to get decomposed. So HF will have most thermal stability, then HCl, then HBr, and the lowest will be of HI. Are you guys done? See, all of these things now, these are dependent on bond energy. All of these things are dependent on what? These are dependent on bond energy. And bond energy is inversely proportional to size. Size increases, the bond energy decreases. Okay, only Ahmad is done. What happened? Fatima, Malia, Mariam, you're not writing now? Achha. Very good, very good. Mariam, Nazira, Sania. Okay, everyone is done. Now write physical state. Physical state here. See, all of these hydrides, or rather I should say the compounds of that is made with hydrogen of halogens, they are what? All are gas except HF. All are gas except HF. HF exists in liquid state. Can somebody tell me the reason?
Because it forms hydrogen bonding.
Yes. Due to the formation of, please write these things with me, formation of hydrogen bonding. Okay. Now the hydrogen bonding, the structure that you will see in hydrogen bonding is like this, and this is important. Okay. So these are hydrogen bonds. This is hydrogen bonding. Okay, so the whole shape is what? It is angular shape. This is angular in shape. Next in physical state, outer physical state, we will talk about its boiling point. So physical state is what point? Wait a second, B. This is will be E. F point will be boiling point. Okay. So in boiling point, we know that HF, it will be forming what? It is liquid, na? It is liquid, so it will be forming hydrogen bond. So we will take it as first, and after that we have HCl, then we have HBr, then we have HI. Okay. These things do not have H bonding, so we will just see the molecular weight. So the first will be obviously HF, will be highest, then will be HI because its molecular weight is high. Then it will be HBr, and after that it will be HCl. Now melting point is important, and there is some difference and the expected and the actual situation of melting points. Remember, melting points, when we look at melting points, we should look at the packing. I've said it many times, whenever we look at melting point, we should look at the packing. Melting points. So some people will say that HF will have higher melting point, right? Due to this hydrogen bonding. But see, this is the shape of HF in solid state, right? Hydrogen bonding with hydrogen bonding. With hydrogen bonding, this is the shape. If you look at the packing, it will be like this. Now, in this type of hydrogen bonding, what happens is that there are H bonding within a layer. Within a layer. That means this part here, this will have hydrogen bonding. But the next layer that is here and the first layer, they won't have any hydrogen bonding between them. Okay. So we have hydrogen bondings within a layer, but no hydrogen bonding exists between the layer. Exists between the layer. Okay. So that is why the order that we get is the first one is HI, and after that we have HF, and after that we have HBr and HI. Okay, I forgot HCl. No? HCl, HBr, and after that it will be HCl. This is the order of melting point. Write this point also. Okay, there are hydrogen bonding within a layer, but no hydrogen bonding is existing between the layers.
Yes, sir.
Is everyone done? You guys are not making that presentation. Your seminar topic is there now. Nobody
Yes,
sent me.
they're working on it.
Working on it. Okay. So if you will be working on it and you will be completing it just one day before the presentation
Sir,
schedule.
I don't even know when the seminar is. Like, we are still doing alcohols, phenols, and ether.
So Mariam said na, that you won't be taught P block elements.
Yeah,
You
we
have to.
won't be taught, but they should at least start the chapter. They did not even start the chapter, which means that we have plenty of time to complete that.
Okay. So what is going on in alcohols? Have you guys started phenol?
Yeah, we started phenols, and by next class we will complete it. We'll be starting with ethers.
So Mariam is saying that I was waiting for us to finish here. You have group 18 na, Mariam?
Yes.
Group 18 will be, I don't know, maybe till on Wednesday I will try to finish it. On Wednesday I will try to finish it. There are
Okay.
few things here. Okay, for example, okay, then what I can do is now see. I've been teaching you a few things which are not included in your syllabus for this year also. For example, we are going to learn about oxyacids now. Okay, so in oxyacids, if you see the syllabus, you will be seeing that there is a bracket and they have written structure only. So what I will do, I will just teach you the structures.
Yes, sir.
Okay.
And also the
Also the
reasons for those structure.
I mean structure. Oh, it is easy. That structure is easy. Oxyacids of halogen, the structure is easy. Okay, there's only one OH bond, and the others are they have double bond oxygens. Okay.
Yes, sir.
What can I write about chlorine? Chlorine will be done. Obviously, chlorine will be done by next class. See, then we have to study about interhalogen compounds. Okay, so in that interhalogen compounds, that is short there. Then we have to do some hydrolysis. Okay, then oxides are there. Oxides will be also oxides will be there, and after oxide we can learn about chlorine and hydrochloric acid, and then we can start group 18. We can start, Mariam. We can start, at least we can start on Wednesday. I don't know about finishing the group 18. We can start. So if we are halfway in group 18, then what we can do is we will leave it there. Then on Saturday, that is the next Saturday, we will complete the group 18, and then we will do questions.
Yes, and no
That's
news.
fine. Yeah. Now there is one thing that I want to ask you about biomolecules. Acha, can it happen that I send you notes for biomolecules? And I will just explain it. It very much seems like what your teachers does in school, but biomolecules, I mean, what do you think?
So what are biomolecules?
What are biomolecules? There's one chapter in organic chemistry, na, the last chapter before polymers, I guess. Polymers is not included in your syllabus. The biology student must be knowing about biomolecules. Yes, Mariam, have you learned biomolecules?
Yes.
Yes, we have learned biomolecules. Okay, so that will be easy. So in biomolecules, what do we have? We have generally that glucose, sucrose, and carbohydrates. Then we have
So why
amino
not
acids.
you give us seminar? Like you give us seminar.
I give you seminar on PPT. You are saying, that will be okay, no? In PPT, I can teach. So I don't have to write. Most of the time is wasted because I have to write each and everything. Okay, fine.
Yes,
Okay,
sir, you can
biomolecules, then I
understand.
guess in one or two class we can finish biomolecules. Okay, so I guess by next week, inshallah. Okay, no, I will not say good things. अच्छा चीज बोलो तो होता नहीं है यार. Because जानते क्यों नहीं होता है? Nobody says माशाल्लाह और इंशाल्लाह. इसलिए कुछ होता नहीं है. इसलिए अच्छा चीज बोलो ही नहीं. क्या करना है क्या नहीं.
Inshallah.
हाँ इंशाल्लाह. ये सब नहीं कहते ना. ठीक है. So let us see what is going to happen. चलो all the best.